Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi guys. So we're gonna move on to the topic of differentiation. So this is actually exactly the same as the differentiation from your O-level, but for your level we're just gonna cover a small part of it. We're not gonna do trigonometry, exponential, or logarithm. So just polynomials. So we're gonna call this differentiation part 1. So it is best if you can print out the notes, and as you listen to this video simultaneously you'll be doing your notes. So what is the meaning of differentiation? So for me it's best if I teach you the mathematical part of it first. Later then I will teach you the meaning of it. So we're gonna skip this first, right? So I'm just gonna go through this page briefly. Right, you have done this, most of you, so you can just have a read. So here I'm just trying to explain you the notation of differentiation, on how to write the notation, because that is very important. So for example, if you have this function y equals to 2x cubed plus 5x minus 1, if this is, we call this as a function y in terms of variable x. So if you want to differentiate it, you're going to have to write it as dy over dx. What dy over dx means is actually the differentiation of function y with respect to variable x. So you're going to have to write it as dy over dx. Don't worry about the answer. We're going to teach you how to do that later. So just focus on the writing of the notation. So if you want to use fx to express your function, because you know this, you can sometimes use y or we can use fx. They are the same, it's just different way of writing it. So if you're going to use fx to express your function, so if you want to differentiate it, so you don't use dy over dx, you're going to use f dash x. Okay, so this is the meaning of the differentiation of function f with respect to x. So like so, right? So both of these are the same, exactly the same. It's just different in the way of writing it. Some books they might use y, some books they might use fx. Okay, so over here I try to explain a specific kind of functions which you will be dealing with later. So for example, if you look at this formula, area of circle, so this is actually a function of a in terms of variable of r, because r can vary, right? So pi here is a constant because it's a fixed number, right? So it's just the same as 1, 2, or 3. Okay, so if I want to differentiate function a with respect to r, which you will do later, you're going to have to write it as dA over dr, which means the differentiation of function a with respect to r. Okay, so next I'm going to talk about second differentiation. So you can do further differentiation. Alright, so for example, if I have function y, we know that if you differentiate the first time, you have to write it as dy over dx. If you want to do the second differentiation, you're going to have to write it as d bracket dy over dx, which means the differentiation of your first differentiation with respect to variable x. So if you simplify this, okay, if you look at the maths here, we're going to have d square y over dx square. So this d square y over dx square means second differentiation. Okay, so if you want to do further differentiation, for example, third differentiation, if you look at over here, you're going to have to put d bracket second differentiation over dx. Simplify that, you get d cubed y over dx, the whole thing cubed. So this is the third differentiation. If you want to do the fourth differentiation, apply the same method. Okay, but for this level, you're going to do at most 2 differentiation only. Okay, but it's good if you know the understanding of this. So if you use fx to represent your function, okay, for example, fx is equal to this, you know that the first differentiation is f dash x. So the second differentiation will be f double dash x. So further differentiation, f triple dash x means the third differentiation, and so on. So the writings of the notation is very, very important. Okay, so you need to write properly. So now we're going to learn how to differentiate. Alright, so before this we know how to write the notation. Alright, so now we're going to learn how to mathematically differentiate. Okay, so we're going to be dealing with polynomials only for this level. Alright, so we're not going to touch trigonometry, exponential, or logarithm. So you remember the definition of polynomial? If not, try to Google it or read this. So it's going to have this kind of form. Okay, in general, it's going to have y equals to ax to the power of n. So where a is a constant, x is the variable, and n is the power. So how am I going to differentiate this? So you just follow this. So if you have y equals to ax to the power of n, the differentiation dy over dx is equals to a is the constant under multiplication, right? So you just copy it and then set it aside. And then you bring down the power in front and then multiply it. And then finally you minus the power with 1. You always minus it with 1. So for example, I have y equals to 2x cubed. 2 is a constant under multiplication here. So you just copy it and set it aside. Okay, and then the power 3, you bring it down as multiplication. And then finally the power 3, you always minus with 1. So simplifying it, you get this. Right? So it's pretty straightforward. So another example is 5 over 4 x to the power of half. 5 over 4 is a function, is a constant under multiplication here. So you just copy it and set it aside. And then the power you bring down. Half you bring down, multiply, you get 5 over 8. And then the power half later, you always minus it 1, you get minus 1. So done. So that is the differentiation of polynomial functions. Done. So there are a few things that you need to take note on. So the first one, if you have a function of polynomial, for example, y equals to 2x, alright, to x to the power of 1. So if you want to differentiate this, it's always going to be 2. So if you have y equals to 3x, if you differentiate 3x, you'll get 3. If you have 5x, if you differentiate 5x, you'll get 5, and so on. Do you get the pattern? So this is the workings, the reason behind it. So just have a look and try to understand that. Another thing is constant. If you have constant, if you differentiate constant, you're always going to have 0. So for example, y equals to 5, a constant, not under multiplication. So it's just constant. If you differentiate it, you get 0. If you have y equals to 1000, differentiate it, equals to 0. So the reason is this. So just have a read. Okay? Alright, so as I said before, polynomials can have more than one terms. Okay? So you can have 2, 3 terms and so on. So for example, I have this. Y equals to 2x cubed plus x to the power of square root of x minus 5x minus 10. So this polynomial has 1, 2, 3, 4 terms. So how am I going to differentiate this? So easy. So you just differentiate it term by term. Okay. So for example, 2x cubed. If you differentiate 2x cubed, you'll get 6x squared. Alright. So square root x is the same as x to the power of half. So you always try to change square root into the power of half. Alright. So x to the power of half, if you differentiate it, you'll get half x to the power of minus half. Alright, so you can just try to understand the working here if I'm going too fast. And then minus 5x, if you differentiate it, becomes minus 5. And then 10, if you differentiate it, becomes 0. So that's it. So if you have a function with many terms, you differentiate it term by term. Okay, also be careful with the sign here. Okay, the sign of the terms, you have to include it. Okay, for example, 5x has the sign of minus, and then 10 has the sign of minus, so it belongs to this term. So if you look at these examples, try to understand it. It's the same thing. Okay. Right, so next one, I'm going to discuss about composite function. You've heard this from the topic of function. So composite function means a function inside a function. Alright, so for example, if you have this function y equals to 3 bracket 2x minus 4 to the power of 5. So we consider this as a composite function. So let's try and break it down. So imagine that 3 bracket to the power of 5 as the outside function, and 2x minus 4 is the inside function. Do you get that? So how are we going to differentiate this? So we have to use chain rule. Okay, the shortcut of chain rule is the differentiation of outside function multiplied by the differentiation of inside function. Okay, so remember that the outside function is 3 something to the power 5. If we differentiate 3 something to the power 5, we copy 3 here, alright? And then the power of 5, you bring it down. And then finally, you minus the power with 1, 5 minus 1. Do you get that? And then what about the inside? You just copy it. Don't change it, just copy it. Alright? That is the differentiation of outside function. And then we deal with the differentiation of inside function. What is my inside function? 2x minus 4. Differentiate 2x minus 4. 2x becomes 2. Minus 4 becomes 0. That's why I have 2 here. Then you simplify it, you'll get this. Alright? So if you do a lot of practice, you'll get faster. But it's good to write this thing. Differentiation of outside times by differentiation of inside. Just to help you keep track of your differentiations. So let's try another example. For example, if I have this, y equals to 4 square root of x squared plus 3x. So if I rewrite this, always change square root to half, power half. So this is actually, in the end, you have this. So again, this is a composite function, a function inside function. So what is the outside function? Is that 4 something to the power of half, right? Can you see that? And the inside function is x squared plus 3x. This is the inside function. This is the outside function. So using chain rule to find dy over dx is the differentiation of outside. Let's deal with this first. So you have 4 something to the power of half. So 4, you just set it aside, you copy it because it's under multiplication. And then half, you bring it down, multiply. And then finally minus the power half with 1. What about the inside? Just copy it, don't change it. Done. So we're done with differentiation of outside. Next, we deal with the differentiation of inside function, which is x squared plus 3x. We have 2 terms here. So differentiate this term by term. X squared becomes 2x, 3x becomes 3. Alright? So give bracket here. So we simplify it, you'll get this. Alright, so this third example you can try and try it yourself. Okay? Alright. So if you look at this function, it looks complicated, but don't be scared by it. Just try to analyze it term by term. As you can see here, we have 4 terms. Term 1, term 2, term 3, and term 4. And then we analyze the term one by one. So term 1 is just 2x. That's easy. It's just polynomial, normal polynomial. If you look at term 2, x plus 1 to the power of minus 1. So this is composite function. Okay? And then if you look at the third term, also composite function. And then finally, the fourth term is just constant one. So be wary of the signs, okay? So each term, they have their own sign. So you have to include the sign. Alright, so how do I differentiate this? You differentiate it term by term. You can do a side working, right? For example, this one. So 2x differentiate, I have 2. X plus 1 minus 1, if I want to differentiate this, I'll get this. Composite function, these two composite function, when you differentiate, you get this 2. And then 1, which is a constant, if you differentiate, you'll get 0. So if I'm going too fast, you can do side workings. Alright, so lastly, you need to have your good algebraic and indices skills to change this form into a proper form like this. Alright, so in the end, you have these exercises that you can try. I've provided the solution as usual. Try your best to do it. Refer to the notes. Do the notes first. And in the end, you try this exercise. Okay, so sorry if I'm going too fast. I only have 15 minutes to do this video. If you have any questions, try to reach me. Okay, if you need for me to do supplementary video, I'll do it. Okay, but just please inform me. Okay, so thank you.